Okay, well, let's kick it off. Yeah, like I said, I'm James. I have the distinct honor to be able to work on multiple runtimes that folks are using. I've been involved with Node since about 2015. One of the core contributors there. Um, I also sit on the technical steering committee with a number of other folks, and I'm responsible for a lot of the things like URL, abort controller, web crypto, web streams. When I say I'm responsible for them, I initially introduced them, and then lots of other people came along over the years to improve them. Kind of the way I like to joke around about it is I add the bugs, other people come into the project to help fix them. But a lot of those kind of web standard APIs that you are starting to see in Node are really things that I've been pushing for the past few years to get in there. Also involved with things like HP3, HP2, getting those in there. But I also work on the Workers runtime, the Cloudflare Workers. I'm a principal engineer on that team, where I work on both the our production environment and our open source core. It's called Workerd, which is kind of just the kernel of the part that actually runs the JavaScript and runs the WebAssembly within that runtime. I'm also the founder, one of the co-founders of the WinterCG, which is the Web Interoperable Runtimes community group that gets all of these runtimes like Node and Dino and Bun and Workers and a number of others together to kind of collectively talk about these standard APIs that they want to that everyone wants to be using. So what's the goal with this particular talk? Really, it's to give a bit more insight into the internal workings of Node by comparing it to Workers. These are, in some ways very similar, but in other ways, very, very different runtimes. Even though they're both based on V8, they both run JavaScript. They're, the way that they work is quite a bit different. And the big thing that I want you all to be able to come away with is just more of an insight into the internal workings of Node by comparing it to another environment that's quite a bit different. So let's talk about the similarities first. Like I said, both use V8 to execute JavaScript WebAssembly. Both are implemented using a mix of C++ and JavaScript. Both provide implementations of web platform APIs. So if we look at what's called the WinterCG Common Minimum API, this is a set of APIs that you'll also find in web browsers that are implemented in Node, they're implemented in Workers, they're implemented in Bun and Dino to various extents, and they're coming along. But the idea is that this is a common API surface for common tasks, like if you want to stream, if you want to parse URL, that kind of thing. That's really where the similarities end between these two environments, between Workers and Node. So let's start to kind of break down what what those differences are. Let's start with the process model, specifically looking at Node. When a Node process starts, right? Let's ignore worker threads for just a few minutes. When a Node process starts, there are several things that are going on. There's a main thread, right? And then there's a pool of IO and garbage collection threads. The garbage collection threads, the IO threads, don't run any JavaScript. Basically, they wait for you to request code to read a file, or to wait for a network request, or to perform some crypto operation, or V8 will trigger it to to go through and do some garbage collection. Importantly, though, those threads never run JavaScript, right? JavaScript is only ever run on this main thread. Again, we're going to ignore worker threads for just a minute. And in that main thread, we have an event loop, which is bound to that thread. And we also have this idea of this environment, which is a node concept. It's kind of the underlying internal state of that node, of that thread. This is, holds all of Node's internal state. It holds the, we create a bunch of strings and objects that we hold in memory for performance reasons. All that goes into that environment or the realm. The other thing that's attached to this environment is the V8 isolate and the V8 context. And importantly, whenever you have a single thread in Node, this main thread with the one event loop, there's always one V8 isolate that's attached to that for the entire lifetime of the thread in Node. And what that V8 isolate is this is the piece within V8 that actually runs the JavaScript. This is the interface that we have to say, okay, this is the virtual machine. The V8 has the maintains the heap, the memory allocations for JavaScript. The context maintains the global state. So anytime you attach something to global this, anytime you have you compile any function within a particular context, it's kind of it's with one logical environment. Importantly, that isolate and the main context exists for the entire lifetime of that thread, and the entire lifetime of that that event loop and that environment. There's only one, and all of the nodes JavaScript that it loads on from its standard lib. So if you look, like require FS or require net, that's all JavaScript that's being loaded with the user's JavaScript and modules in that one V8 isolate and in that one context, right, in that thread. And that lives for the lifetime of that thread. Very important. I'm stressing that because it's a key difference with the way that Workers operates. Okay, so again, the IO threads, they're there. There is at least 4 or 5 of those per process. I think it's like 4 libuv threads, and then 1 or 2 threads from V8 with garbage collection, and then there's that main that main node thread. Now, a worker thread within Node, bringing back to that, is just basically a snapshot of the exact of that main thread. It's just another instance of that. It has its own environment, its own realm, its own set of the JavaScript. It has its own isolate as well, and those can you can have any number of those within your Node process, but essentially they're a complete Node environment just copied across multiple threads. Right? Okay. So the event loop monitors IO. When IO completes, the event loop triggers a callback to run. So user code calls, FS want to read a file. That request to read some bit of file data is going to go into this IO queue. One of your IO threads is going to pick that up, go off, read that little bit of file, and then tell the event loop, okay, I've got the file data, I'm ready. When you're ready to notify the user code. And then the event loop will turn. It'll hit that. It'll see that file, bit of file has been read, and then it'll go off and execute some bit of JavaScript. Okay. When it does execute that little bit of JavaScript, there's a few very important things that actually happen there. But let's, we'll get into that in just a second. I just want to kind of talk through kind of the life cycle of the event loop here. When the node process starts, we'll run a little bit of entry point JavaScript. So when you say node, foo.js, it's going to run that code first. If that code does not schedule any IO, if it doesn't go off and read a file, if it doesn't schedule a timer, if it doesn't tell a server to start listening, then as soon as that bit of JavaScript runs, the node process is going to exit before it ever actually starts the event loop. If that bit of entry point JavaScript does schedule IO, right, then we'll kick off the event loop, and it'll just keep running until that IO is completed. If it sees that a timer is fired and there's nothing else left, or if it read a file and there's nothing else left to do, then the event loop will exit and the process will exit immediately, right? So it just runs just long enough to handle the exact bit of IO that was been asked to run. Okay. It's very important in terms of this life cycle of how Node will start up, and just keep monitoring to see if there's IO. And as soon as there's no other tasks on that event loop to complete, it's done. It exits and the process finishes. Okay. Now, in that event loop, when it does detect that it needs to, call back and let somebody know, let the node process know that that bit of IO has finished, it's very important to understand what happens. And the reason this is important is because this picture that you see right here is the most critical thing you need to understand Node's performance, or how to make things fast in Node. The event loop is turning, right? It's basically just a for loop that's always turning, always going, always iterating. And within that for loop, there are a number of spots where it will invoke callbacks, right? Now, whenever it invokes a callback, we're going off and basically just calling a C++ function. While that is being called, while that function is running, the event loop stops. It is blocked from doing anything else. Okay. So we have, here at point 1, we call, the event loop calls back to some C++. The C++ says, okay, this needs to execute some JavaScript. It will call into JavaScript, into that V8 isolate, execute that JavaScript. All right. That can do all kinds of things. It can schedule more IO. It can, print to the console. It can also call, process next tick. It can resolve promises or whatever, right? As soon as that control returns back to C++ from the JavaScript function, we have this process that'll go off and drain the next tick in the microtask queue. So what that means is, as soon as that JavaScript function returns to C++, we'll go off and check, did you call process next tick at all? Or is there anything in that queue? If yes, it'll just go execute all of those functions and completely drain that queue. If you've resolved any promises, right, it will go in and check, okay, is there anything in the microtask queue that needs to be taken care of? Yes, it will drain that queue entirely before the event loop is allowed to continue on. All right. So, if we're thinking about with Node, think about going back to this idea here, whereas the one event loop is turning, it has to go off and like, okay, is this file been read? Is this connection available? Is this bit of crypto, this crypto operation complete? Every time it asks those questions and has to go back and invoke some JavaScript, anytime there's JavaScript running, the event loop is stopped, which means anytime JavaScript is running, Node can't go and accept another request. Anytime JavaScript is running, Node cannot go finish reading a file. Anytime JavaScript is running, it can't, go, complete another crypto operation. So there's this back and forth between what Node is, currently doing, what, that JavaScript that's running, and what that event loop is allowed to go off and continue to do. This is why we talk, when we're talking about Node performance, when we talk about how event loop delay or the event loop block is so important to Node, that you have to make sure that anything that you're telling it to do is running in these very, very short periods of time. And it's very important to optimize your application to run in these small, discrete chunks, because anytime you're taking too long, anytime anything is too compute intensive, it's going to block that event loop from doing anything else. Okay, so when Node is running as a web server, right, which it doesn't have to, this is one of the key differences between Node and Workers, is Node can be anything. It can be a CLI app. It can be, it can run a web server. It can, be on the client side and something like Electron. It's very, very flexible. But when Node is running as a web server, that initial entry point JavaScript has to create and start the server, right? That happens in JavaScript. This schedules an IO task on the event loop, basically wait for socket connections. Whenever that new socket connection is received, the event loop triggers a callback function that executes some JavaScript that goes off and parses the HTTP request, figures out where, how it's supposed to be handled, figures out, parses out all the HTTP headers, validates those things that they're correct. All of this stuff is happening in JavaScript within that one event loop. So all of these things add overhead, right? Like I said, anytime there's JavaScript running, the event loop's not. So when we receive a new request, it, and just that parsing overhead of, how do you, pulling out those headers, determining kind of how we're going to handle this particular request. All of that stops you from being able, stops that node process from being able to accept the next request until that is complete, until that's done. So we have to make sure, in order to make Node faster, we have to make these times as small as possible. The amount of time parsing out a header, the amount of time to how to route the request. All of these things have to be minimized as much as possible. And anytime you see any kind of performance difference between, say, Express or Fastify or any of these other frameworks, it's because they've taken, the faster ones have made more optimizations on on these particular pieces, the parsing of the headers, the determining where to route a particular request or how to route it to what other bit of code. It is minimizing how long that JavaScript takes to run. Very, very important to keep that event loop delay as small as possible. So this, and it's just an illustration of the point you're just making here, is that, you have one event loop that is handling all of these requests. And it has to multiplex these things, work a little bit on request 1, work a little bit on request 2, go back to working on request 1. There's this time sharing in the event loop that has to happen. And this is a very careful dance in order to get the performance that you need out of this particular runtime. Request per second is entirely dependent on how quickly each individual callback can finish and return control back to the event loop so it can move on to the next task. All right. I had one case in particular, for instance, this was years ago when I was doing consulting work, where in the event loop, the application would go off and parse some GraphQL, a very complex GraphQL query. It would go off and fire off all these background tasks, these background queries to other servers. But the event loop was being blocked for so long that by the time the event loop came back around to execute the timers, right, even though the backend servers had already responded with data and that was sitting in the event loop queue waiting to be processed, the event loop was being blocked for so long that the timeout timers would fire and throw an error and say, hey, things took too long to process, and it would cause errors throughout the application, simply because that event loop was being blocked for so long by going off and executing this large chunk of JavaScript on every request. So it's very critical that we get this piece right in Node, that you keep these tasks, these individual callbacks, as small and as fast as possible for the node, for that Node event loop to roll over and move on to the next task. Few other key characteristics with Node. All code is trusted. If the code runs in the process, it's considered trusted. It's all considered one application. It doesn't matter if you have, however many worker threads you may have running. You have the main thread, you spawn any worker threads. It's all still considered one application, single tenant. Worker threads are allowed to share memory back and forth. They're allowed to pass messages to each other. There is no trust boundary there between those worker threads, even though they all have their own isolates. And there's no trust boundary between the node process itself and the operating system. If that node process can have any access to the file system that the user account that it's running under has. So very, very critical idea there in terms of that code being trusted. Now we are starting to introduce the permission model in Node to kind of restrict that somewhat, but for the most part, it's any code that's running is trusted. All HP request dispatching happens in the main thread with the same, along with the code that is processing that request, parsing it all out. All of that happens in JavaScript. Again, going back to the performance characteristics, very important that happens as quickly as possible. Node can do a lot more than just handling HTTP requests. This is another key difference from Workers. Workers is a much more opinionated, much more focused runtime that is primarily designed for handling HTTP requests. I mean, it can do a few other things, email and a few other things, but it is very much focused on that HTTP server model. Node, however, of course, it can do anything. So it's a lot more flexible in terms of its use cases. But the design of it is much more susceptible to these event loop delays if they're very compute intensive tasks. All right. So what about workers? First, let's back up and define what a worker is. So with Cloudflare Workers, our environment, we have this global network of, basically servers running in locations all over the world. With a worker, you deploy this bit of JavaScript, this application to our network. It doesn't matter where in the world you are. whatever server your request ends up at, we can take your application and run it on that server and handle your requests. So one, you don't have, it's not just one process running. It's actually, on one of, probably 25,000 processes around the world that your application could be running on somewhere, right? So we're not limited to a single region. We're not limited to a single environment, a single metal. It can be anywhere. And we'll automatically handle deploying that application for you. But what is that application? What is a worker? Essentially, it is just a bit of JavaScript. Even if it's a WebAssembly application, or still this JavaScript entry point that is handling an HTTP request. Now it can do other things like handling a scheduled task. We have cron triggers and alarms. You can process logs from other workers. There's other things we can do, but it's primarily handling an HTTP request in and out. So from the browser, you type in an address, you send a request, it's going to come in, run that little bit of JavaScript for that worker, respond. That JavaScript can do sub requests back to an origin server, anything. But yeah, the basic idea, the fundamental idea is request comes in, we call this fetch handler, handle the request, provide a response, and move on from there. That's what a worker is. Very, very simple. Think of it, the easiest way to think of it is just a fetch handler, right? Receives a request, responds with and gives a response. A worker cannot be a CLI. This is important. Again, Workers is primarily a web server environment. Okay. A worker consists of a bundle of modules and bindings. Modules are anything like ESM, CommonJS, WebAssembly. It can be text, just static text. It could be static binary data. It could be JSON. These are things that you provide to the worker. This is your code. This is your data. A binding is some capability like fetching to a private network or using a specific KV store. These are the features of the runtime of Cloudflare features or other capabilities that the runtime will inject into a worker. These are your interface with the outside world, basically. A worker always has a main module that exports at least one entry point handler, which is most typically that fetch handler, that request response. Okay. With Node, right? When you say, node foo.js, that entry point is that file that you give it. It's just going to run that from top to bottom and complete it. A worker has some bit of setup code that can run right when the worker is created. But that setup code is not allowed to perform any I/O. So it can't do a sub request. It can't schedule a timer. All it does is basically just set up this entry, this fetch handler, these export handlers. And then the runtime will handle calling those functions, like the fetch function or the alarm function. It will handle those based on whatever type of request it is received. And only those requests can actually perform I/O. So you can only schedule a timer, for instance, if you're in the process of handling a single request. Now, if we go back to the process model a little bit, how does the workers process differ? Well, when we start the workers process, there's a single thread. Okay, the single thread will do the initial bootstrap, say, all the initial configuration and set things up. But where it differs from Node, where you have one main thread that with one event loop that is handling all of the requests, right? It doesn't matter how many requests you get, that one main thread just handles all of them. What'll happen differently in the workers process is that we'll start that first main thread and it will start to listen for requests after it's done its bootstrap. Once it receives a request and starts processing it, it will spawn another thread to wait for the next request. And it's set up so that it'll always decide, it'll always make available another thread to handle the next request that's coming in. And so we can start handling one request, and it's, I'll show you how that thread model looks in just a second. But it'll start handling the request, but it'll always spawn this additional thread to handle the next one. So even while that one request is processing, even if it's fairly compute intensive, there's always something else available that can take on the next request that's coming in. So this is key difference from Node is, while you're processing one request, it can't do other things, right? Here with workers, we're always, spawning that out where, okay, there's at least going to be another thread that can handle this. Now, once we've fully saturated that machine, then we'll start queuing things up, and we start seeing a lot of, kind of that event loop kind of blockage that you see in Node. But it takes a while to get there, with this multiple thread model. Now, within a workers connection thread, we do have an event loop, right? That thread will come in, it'll wait for a connection. Once it receives the connection, that thread's event loop will start handling all of the IO. It'll make sure that the stream data is read in. But the thread, before we execute any JavaScript at all, right, on this thread, once we get the connection, we'll do the HTTP parsing. We'll look at the headers. We'll figure out what worker needs to be invoked. We will figure out all of the routing in advance before we execute any JavaScript at all. And this is another key difference from Node. Whereas Node, when it receives that request, all of that HTTP processing happens in JavaScript, right? It's while that code is all of those determinations are made from JavaScript itself. Okay. With workers, that's all done before any JavaScript is executed, right? We'll do all of that parsing, all of that routing, all of that figuring out kind of what needs to run before we ever actually run any JavaScript at all. Once we've made that determination, then we'll look at the actual handler, the fetch handler that the worker has exported, and then we'll invoke that. And it runs for just a single request, right? So once that thread calls that function, gets the response, right, that connection ends up going away, and the thread keeps rolling over and waits for the next connection to be received. So this one thread, right, just keeps looping, handling one connection after the other. Now, importantly, the isolate, if we go back to Node, where I said the one worker thread or the one main thread has one isolate attached to the entire flow, to the entire lifetime of that thread. With a connection with the workers thread, right, the isolate is attached to the worker, not to the thread. So when the thread picks up a connection, it says, okay, I need, and identifies which worker it wants to, that request is for, then it will just temporarily lock that isolate to that thread, execute a bit of JavaScript, and then release the lock, move on to the next connection, figure out the next worker, take its isolate, lock its isolate, run it. So this thread can actually have multiple isolates on it, only one at a time, that are being locked and unlocked from this one thread as it rolls over and continues to accept requests. Now, in one process, like I said, every time we have one of these threads, it spawns another one. We can have thousands of these threads running concurrently within a single process, handling thousands of workers at the same time. So again, the key point for raising that, for describing that, is really to get you to understand, start thinking about how Node is processing requests internally, how that event loop is turning, how various actions that you're taking in a callback might be blocking other things from happening, right? Node doesn't have this idea where it's spawning a new thread every time you have a request to make sure that there's, it can handle another request. It's just one event loop, one thread turning over, unless you have worker threads and you're managing that dispatching yourself. It's just going to keep, running that one event loop. You run some code, and anytime your code's running, it can't do anything else. Right. So kind of, a little bit of a summary here. Workers versus Node. Key differences: with Node, the V8 isolate is bound to one thread for its entire lifetime. With workers, the V8 isolate is bound to the worker, which runs on any thread, right, currently handling a request for that worker, but only one at a time. Okay. With Node, the thread will run for as long as there is IO scheduled. So as long as you have a timer scheduled, as long as you have a server waiting for requests, the Node process will just keep running. With workers, the process runs indefinitely, just waiting for requests. It'll run indefinitely until we stop it. It doesn't have this notion of, okay, is the event loop not doing anything? Okay, we're done, and exit. It will just keep waiting for requests indefinitely for as long as that process is running. With Node, receiving an HTTP request, parsing it, determining how to route it, all happens in JavaScript. Now, that JavaScript will use some C++ code, like for the HTTP parsing, but it's still running JavaScript that's calling back down into C++. And all of that, anytime JavaScript is running, the event loop is not. So we have to be very careful, not to block the event loop for too long. With workers, receiving that request, parsing it, determining how to route it, all happens before JavaScript is run. And it's done in a way that allows that event loop to continue doing other things if appropriate. We have asynchronous. We actually have a promise model at the C++ level that we use to ensure that multiple things can happen much more efficiently. And every request is potentially handled by a different thread. With Node, the event loop and promise microtasks are distinctly separate things. Callbacks do not equal promises. Anything that's running on the event loop will have this callback model, and that's when you see Node's traditional callbacks. Like when you use the FS and you read and you pass back a callback function. That's event loop driven. Promises, however, in Node have nothing to do with the event loop. It's just, promise gets resolved, it goes into the micro task queue. Anytime you run JavaScript, anytime control returns back to C++, we go through and we drain that micro task queue. And that can happen thousands of times on a single event loop tick. Depends on how much activity that event loop is using. But those are very different things. With workers, the event loop is entirely promise-based. So we have, anytime the workers event loop runs and it resolves a particular task, we're actually resolving promises there. There is no concept of a next tick or set immediate or this, these other queues. It's just that event loop is driving the micro task queue in JavaScript. Okay. A couple other differences. The thread the thread will not exit if the event loop still has IO tasks. With workers, when a request is complete, all pending IO tasks associated with that request are canceled. So if you have a request coming in, we'll see an example of this in a minute. When you have a request and you schedule a timer, if you don't tell the runtime to specifically wait on that timer, if you go ahead and return a response, then the worker's runtime will just cancel the timer, and we'll just stop. It'll never fire. There's other IO if you're waiting for a fetch sub request. If you don't tell the runtime to wait on it explicitly, it won't. It'll cancel it. With Node, whenever you schedule any kind of IO, Node will just wait indefinitely for that thing to be done before it'll exit. Before it won't go off and proactively cancel anything. And we see a lot of people kind of get confused by this. It's like, hey, I set up a timer in workers. Why isn't it actually firing? Well, it's because you can only set it up in a request and you didn't tell the runtime to wait on it. So this is a key difference here between these two. Node always waits unless you tell it not to. Workers will never wait until you tell it to. Okay. With Node, all code processes are considered trusted. Talked about this, the security model. If the code runs in Node, it's trusted in Node. With workers, no code is considered trusted. Every worker is considered a trust boundary. They're never permitted to share state, share memory. Sandboxing is very carefully applied. So even within this one process, everything is kind of firewalled from everything else. With Node, a single process is inherently single tenant. It's just one application for the entire process. With workers, a single process is always multi-tenant. Because every application, every worker is a trust boundary, and we can run thousands of these at the same time. So there's this distinct separation and distinct difference between kind of what that what Node views as an application and what workers views as an application. It's very important to understand those differences. So let's look at an example. This would be the entry point for a Node server, right? We import, create server, we're creating the server, we're configuring the server, we're telling it that when you receive a request, run this particular bit of code, and we're telling the server to listen. Now, when we tell the server to listen, this is actually scheduling the IO on that event loop to just, wait for a connection, and when you get a connection, you're going to eventually get to where you call this request response method. We're setting a timeout here. It's going to wait a second, then print hello, and we're going to say res end hello world. Now, when this request finishes, the timeout will always be fired, right? Because Node, again, will always wait for this. It doesn't associate this timer with the request at all. It just always will run, right? And then this server will just keep running the Node process until the server is told to stop listening, right? Because that's always scheduled that I/O. Again, if the I/O has something to do, in this case, it's waiting for a connection, it will just keep running indefinitely. But importantly, all of this is run in JavaScript, right? The creation of the server, the configuration of the server, the parsing of the headers when they come in, the determining that we're going to call this handler function that's passed to create server, all of that runs in JavaScript. And while that JavaScript is running, the event loop can't turn over. So this handler function has to return as quickly as possible in order for this application to be able to handle the next request that's coming in. Workers looks quite a bit different. It's quite a bit simpler in terms of the actual JavaScript here. Like here, all we're saying is, we're exporting a fetch handler. We're telling it to, set a timer, and we're telling it to respond with hello world. Notice we don't have to configure the server. We don't have to tell it to listen here, because all of that is handled by the runtime itself, right? The entry point is just the code necessary to set the handler up. That's it. Every request may be handled by a different thread. So even while you're, while this one is running, it still probably is not blocking another request being able to come in and be processed. And the timeout here, importantly, is canceled when the response is returned, because we're not telling the server to actually wait on that timer at all. This timeout, all of these things, any I/O within this worker is always set. Is always associated with that request. So when that request is completed, unless the runtime's been told, no, you need to wait on this, on the completion of this thing, it will just cancel it and move on to the next thing. So that's basically it. The two runtimes are very, like I said, in many ways, very, very similar. But understanding these key differences between how they process tasks is very, very helpful to understanding just how to optimize for any particular platform. So, yeah.
Thank you, James. It was very informative, and I'm very thankful for your support of Ukraine. And we have several questions in our Discord chat. We have questions from Nikita Galkin. He writes, James, you're a champion of a quick HTTP3 initiative. When do we expect this feature with a stable flag? What challenges do the core team have with this feature?
Okay, so great question. So HTTP3 and quick has been coming for quite some time. I've been working on it for a number of years now. The biggest challenge with it is that it is probably one of the most complex bits of code that have ever been added to Node. It's an incredibly complicated protocol. I had a PR sitting there for Node for over a year with it basically working. But it was such a massive PR, such a huge change that it actually got no reviews. Like, folks, other contributors in the project were actually rather afraid to look at it. And didn't quite know how to approach it and doing a review. And it's no fault to them, because it's just, in order to really adequately review the code, you also have to understand the protocol, and the protocol itself is very, very complicated. So I've taken another approach. I've stepped back from that, and I'm doing it like piece by piece every few months. Here's another PR that adds another chunk. Here's another PR that adds another chunk. And I have a PR now that I need to get landed. But it's an attempt to kind of allow it to be reviewed and landed in smaller pieces. So it's taking quite a bit longer to actually get finished. So I'm hoping we'll be able to finish it next year. I'm hoping, to try to encourage some other folks to jump in and help. And yeah, so I mean, hopefully, fingers crossed, next year.
Yes, we are hoping as well. So the next question from Nikita. There is a blog called The State of Node.js Performance. Do you have something the same for workers?
No, we don't. We actually don't go through and as actively benchmark workers like we do with Node. And the reason for that is it is incredibly difficult to do. A single workers process, and we have thousands of these running around the world. An individual process actually at any given time has like 5,000 threads that are running concurrently on all these different things. It can be incredibly difficult to actually get reasonable metrics out to benchmark the same way. And it's just an ongoing problem. An ongoing challenge that we've had is just like how do we get the metrics out? So we have benchmarks that we do run. We don't publish those. It's more for our internal use. But it is an incredibly challenging task, and because of those challenges, which is largely why we don't publish the numbers, because it changes, and it's not clear how much of a benefit it actually would be to the ecosystem for us to publish the numbers.
I see. But actually, what teams would you recommend to move to workers? Maybe specific projects, or you mainly recommend to everybody to move to workers?
Yeah, I'm biased. I want everybody to use workers. Applications, serverless applications. So anything that you would like, build on like AWS Lambda or Cloud Functions or whatever, are natural fit for workers. And again, I'm biased. I think it runs better, and it's definitely cheaper for you if you're running it on workers, simply because the pricing model and a few other things. But yeah, really those kind of applications is anything that can be decomposed into those individual kind of Lambda-like functions.
Thank you. And probably our last question, what is the future of Node.js that you can forecast? What features, trends, and other stuff?
Right. Yeah, with Node, the effort right now with Node really seems to be around performance. So if you look at all of the excellent work that Yagis and a few of the others have been doing with making Node faster, is critically important, and I foresee it continuing. All of the features, new features, other than things like Quick and HP 3. The other new features I really anticipate are going to be focusing on developer experience. So looking at the reasons why people like Dino or like Bun, all these bundled tools, all these bundled capabilities, all of that improves the overall developer experience. It makes things easier because it helps it reduces the number of choices that developers have to make, the number of decisions they have to make. I think that we're going to see a lot of those lessons learned kind of make their way into Node. And Node in general should become much more responsive to what developers are asking for than what the contributors want, if that makes sense.
Yeah, makes sense.
So, yeah.
Thank you so much for your answers. Guys, we can continue in Discord voice chat. We can continue asking questions to James. And thank you for your time. Thank you, guys.